Ladies and gentlemen, it's a great pleasure this evening to introduce to you Baroness Susan Greenfield. Baroness Greenfield is one of the world's leading experts in the physiology of the brain. She was the first woman in history to give the Royal Institution's Christmas lectures and led that organisation for over a decade. If you give me another, give a warm welcome this evening.
Thank you. Well, good evening, everyone. Is the mic on? Yeah. Can everyone see the screen okay, rather than my head? Okay. I'm going to make an assumption that a lot of you perhaps are not scientists. Is that right? You're not all demon neuroscientists here, or neurologists. If you are, forgive me, because I'm going to talk in a very general way for the non-specialist, because I think what we're going to be looking at is of interest to everyone, irrespective of the subject that you're doing. What we're going to look at is, as you know, what is the future for the brain. Now, you might think that's a rather strange idea, because you wouldn't say what is the future of the heart or what is the future of the lungs. It's pretty obvious they'll be doing the same as they've always done. But what I want to show you and explore with you is that the human brain is the most interesting and special, but above all, individual part of your body. It's what makes you the person you are. I don't know if there are any people that have dissected a human brain here, but I always remember, there's a lady nodding, I always remember, I don't know if you've had the same experience, actually holding a human brain in one hand, and we wear surgical gloves, obviously, because it's in a pungent and toxic fixative. But I remember thinking, if I wasn't wearing gloves and I got a bit under my fingernail, rather like in this picture here, would that be the bit that somebody loved with? Or would it be a memory? Or would it be a hope? And I think that's what started me doing neuroscience, actually, was this idea that this sludgy stuff that occupies the same universe as nasal hair, or earwax, or saliva, or tooth enamel. So I won't ask questions, you can sit on the front. There's no the normal fear of being on the front row in case you get asked questions. And that's what got me thinking about what is different about this stuff that gives you currently not just your own individuality, but actually consciousness. And that's something that, again, any philosophers here may have contemplated. This inner world that no one else can share, however much you love someone, however artistic you are, however musical, however articulate, the person sitting next to you now, you will never be able to hack into their world and see it through their eyes any more than they can for you. It will always be indirect and second-hand. So what is it about this thing that you're holding, or I'm holding, or this person's holding, that is so special? Where is it? Where does it come from? It's not made of stuff with different atoms or molecules. It's all the same physical chemistry. So where does the specialness lie? And I think we need to think about that, because it's only when we do think about that that you can see why I think one of the biggest challenges for your generation is to think about what the unprecedented environment of the 21st century, what it means for its impact on your brains and therefore your minds. So there we are, morphing into George Bernard Shaw. You may or may not like him, you may or may not be familiar with his work. I'm sure you know he was. The reason I like showing this is, for me, this is the apotheosis of the individual. You only have to look at those piercing eyes to wonder, what was it like to be George Bernard Shaw? What was going on behind those piercing eyes? Same as what's going on behind your eyes. What made him so special and so individual and so creative? When all that he had behind those eyes is something you could put on a table that would be indistinguishable at the naked eye level from your brain or my brain. Okay, so given that, we need to think about what the individuality that the brain gives you, how that's going to be possibly enhanced, possibly jeopardized by the future. So that's what we're going to look at first. Okay, again, the neuroscientists here, forgive me because this will be kind of bread and butter to you, but it's astonishing for those that don't know about this, because it brings home to you something you might take for granted, which is your own individual mind. So let's think about why you are so special. Why, I don't know if there's any identical twins here, why, even if you're a clone, an identical twin, you are still a unique person. How do you differ, let's say, from a goldfish? And I don't know if you've got pet goldfish at home, but let's be brutal. They don't have great personalities, do they? And they don't, perhaps someone will say they've got the most genius goldfish ever, but if you had brothers or sisters, small brothers or sisters, and they owned a goldfish and the goldfish died while they were at school, you could sneak off and buy another goldfish, and the child would come home and wouldn't know any different, because goldfish do not have a very varied repertoire of behaviour. Now, you couldn't do that with pet cats or dogs, and you certainly couldn't do it with the other brothers or sisters, because the more, much as they might want this, because the whole point is that as we become more sophisticated, so we shift away from the narrow instincts, the repertoire dictated by genes, such as is characterized by the repertoire of the goldfish, through to something that human beings do better than any other species on the planet. We don't run particularly fast, we don't see particularly well, we're not particularly strong. But why is it that we occupy more ecological niches than any other? And that is because what we do better than any other is we learn, we adapt. So you are born, a lovely phrase, as a citizen of the world, but within a very short time, even within a few months, you've already started to specialize to the environment, the culture, the time and the place into which you happen to have been born. This is what we call plasticity. It doesn't mean, of course, that the brain is plastic, but it comes from the Greek plastikos, to be molded. Let's look at what happens in the first 2 years of life. And this is what I'd like to see is the biological basis of the mind. So this is how you started off your life. This is the human brain in the first 2 years. Again, the demon neuroscientists will have seen all this, but the historians may not have too much. So the blobby bits are the brain cells and the stringy bits are the connections. And I hope you can see that, if I throw up the cursor, this is the newborn brain, the 3-month-old, the 15-month and the 2-year brain, where you can see the change, the change is not so much the proliferation of the blobby bits, but it is the growth of the brain after birth that's caused by the connections between them as they push out the brain cells. Now, this means that as your brain and i.e. are interacting and having your individual experiences, these experiences, these inputs, have the chance to change the configuration and shape the pattern of the connections in a way that is unique to you, even if you're a clone. So let's look at an example of that, occurring even into adulthood and throughout the whole of your life. I love this experiment, and I think one could just think about this for the whole evening. So this was an experiment involving 3 groups of adult human volunteers, none of whom could play the piano. And if ever you get the chance to volunteer or be a subject for such an experiment, let me give you a word of advice: don't be the control group, because they just stared at a piano for 5 days. It's not much fun. However, those who were lucky enough to be in the experimental group learnt 5-finger piano exercises. And then we're going to look at the change in brain scans even over 5 days as a result of this experience of 5 days of playing the piano. But there was an even more exciting group, and I'm going to show you those as a surprise, as the 3rd group. So let's look at these over the 5 days. Look first at the control group up here. I hope you can all see it. As you can see, the brain is literally unimpressed. Okay? Nothing's happened ever in this area of the brain controlled by the digits. But look at these guys. Even over 5 days, can you see the change in brain territory relating to the digits? Astonishing. Even over 5 days of just playing the piano. But my mystery group, my surprise group for you, are these people. And they, guess what? They merely imagined they were playing the piano. Is that amazing? So you can see they're pretty much indistinguishable, pretty much the same as those people who are actually physically playing it. So you're starting to see how special your brain is, that even a thought, I'm sure there's philosophers here lurking, they usually are, they usually put their hands up first and tell me I don't know what the mind is and so on. But those who still promote the distinction between mental and physical, between mind and brain, can you see that that's not very helpful? That even a thought can be changed, can be seen in some way with a physical correlate in the brain. It also tells us that the important thing, as far as the brain is concerned, in this plastic adaptation, is not the contraction of the muscle, but the thought that has preceded it. And there's a man called Hornikowitz who developed the still used treatment for Parkinson's disease, a disorder of movement, and he came up with a wonderful phrase. He said, "Thinking is movement confined to the brain. Thinking is movement," which is what's happened here. So I say that we really could put this slide up and just talk about this all evening, but I hope it's proved its point, which is that your brain is very sensitive to the environment. Now, how does this happen? As a neuroscientist, given that we traffic in the squalor of the physical brain, that's not good enough for us. We need to know why and how brains can adapt. And in order to look at the nuts and bolts of the brain at the level of the cells, the neurons, clearly not many human volunteers will give up their brain cells and let you do invasive work on their brains, so we turn to our friends the rats. And here you can see a paradigm. This is from my own lab, where we work with something called an enriched environment. Now, enriched doesn't mean to say they come to the union on a Friday night and have hopefully stimulating and interactive debates and discussions. Enriched for a rat, as you can see here, compared to a normal lab cage, is an environment such as you see here. Anyone who's familiar with rats can see how happy these rats look. They really look as though they're having fun, as they are in these little branches, and they have things to play with, and it's a bigger space, and they interact with each other. So it's a stimulating environment as far as a rat is concerned. Now, if we compare a single brain cell from a rat that wasn't so privileged and was in an ordinary lab cage with one of these people, then this is what we see. Now, at first glance, this is a brain cell. For those who haven't seen it, it might not look that interesting or special. What I want to draw your attention to is the blobby bit here. That's the main part of the cell. And then please focus on these branches that are coming out. And I'll tell you why they're important in a minute. And you'll see that if you compare this brain cell with a cell from the animals that had been enriched, you can, I hope, see a difference. Yeah? The blobby bits are comparable, but can you see the big difference is that here the branches are much, much more extensive. So let's think about that and why it's important. What's happened is a bit like when you exercise your body, and we all know that whatever muscle groups you exercise, they will become stronger and larger. When you make a brain cell work hard, for example, if it's in a brain that's undergoing an interactive, stimulating, enriched experience, then what happens when it's more active, when it's harder working, its response is to grow more branches. Rather like muscles get bigger, brain cells grow more branches. Why should that be interesting or important? Well, let's think about it. If you have more branches, you've got a greater surface area. And by having a greater surface area, you can be an easier target for more and more brain cells converging. Up to 100,000 cells will converge on only one other brain cell. So the more branches you have, and this is the crucial thing, the more connections you can make. So let's recap. A stimulating, interactive, enriched environment activates brain cells, makes them work harder. The response that they will then display is growth of branches, which in turn is increasing the surface area, which means they serve as an easier target for brain cells, which means you can have more neuronal connections. Okay? And that's what happened with the piano players. So let's think about what that means. So in the words of the great William James, a psychologist from the 19th century, you're born as a baby into a booming, buzzing confusion, sensory world. You evaluate the world in terms of how sweet, how fast, how cold, how bright. You can't do anything else, can you? You're a little baby. These are just abstract sensations that are swamping your brain. But can you imagine if a visual pattern, a certain abstract visual pattern keeps occurring, the same pattern, and if that pattern's accompanied by certain smells and sounds and colours and textures and a voice, then gradually, like with the piano players, what will happen is connections will form around that specific image, that specific sensory experience. That means, as it happens again and again, let's say it's your mother, for example, so you will start to recognize that not as abstract senses, but something we call cognitive, from the Latin cogito, I think. So what will happen is you shift from this abstract world into one that has a meaning to you, that is special to you, because only you have had an interactive experience with that object or person in a certain way that will craft your brain cell connections in a certain way. That means you start off in this one-way street where you're going, just responding to everything unconditionally as it floods in. But gradually you will start to evaluate what's coming in terms of what's there already. So you'll start to tick it off against the checks and balances of what's there already. And as you're having that experience, it will modify and incessantly modify the connections, but the connections will determine how you see that input. So you end up with this lovely dialogue between your brain and the outside world, a cognitive experience. So I've deliberately put here some people, hopefully you recognize me there in the middle, but the whole point of this is that you shouldn't recognize any of these other people. I hope you don't. They're all white middle-aged men in suits and ties, and you would judge them like that generically, I'm sure. They happen to be colleagues of mine. I know them by their names. I know their hopes, their fears, their dreams, where they went on holiday, how many kids they've got, their wives' names, because I work with them, or I have worked with them. They mean something to me in a way they won't mean anything to you. Similarly, you could substitute in your family and friends and colleagues, and I will see them as generic men and women. You will see them according to the degree of intimacy, the number of connections that they have for you, as more or less significant to you in a personalized way. So we shift from just judging the world like a small child does, by raw sensations into one that's meaningful to us through our brain cell connections. So this is a little scheme of that. This is a brain cell, rather pretty one in the brain. You can see the lovely, lovely branches. But if you can think of them literally like a tree, and that tree enabling you to make lots of cognitive associations. So the more branches you have, the more connections you can make, the more personalized significance in the world to you. And I want to go one further and suggest that this means you can understand things from a unique perspective. Let's just pause for a moment and think about what understanding is and how it's different from just a fact that comes. How can you understand something? Well, the example I like to give is my poor little brother, who's 13 years younger than me. And when he was 3 and I was 16, I don't know if any of you are in that position, either as the 16-year-old or the 3-year-old, but I used to love torturing him a lot. And this, was physical torture, like holding him up by his feet. There's also mental torture, like forcing him to learn Shakespeare. Because I thought it was quite funny to have this little kid parrot off, Shakespeare. And one of the, and he still remembers it now. And one of the things he learnt was Macbeth, which obviously went down a storm in playgroup and going into something and saying, tomorrow and tomorrow and tomorrow creeps in this petty pace from day to day. I'm sure everyone's familiar with that soliloquy. But there's a line in that, out, brief candle, life is but a poor player. Now, if you'd said to him at that stage, Graham, what does it mean? Do you understand what it means, out, brief candle? He would have said, yes. If you have a candle, like on my birthday cake, I can blow it out. He couldn't have seen the candle as a metaphor for death. How could he? He was only 3 years old. Yeah. So that is what I mean by understanding. It's seeing one thing in terms of something else. And the more you can embed something in relation to something else, I would suggest to you, that's when you understand it. And that's what separates a mere fact, mere information from knowledge. It's seeing one thing in terms of something else. And the more you can do that, the deeper the understanding. So the more connections you can make, the more meaningful something is to you. Now, sadly, this can go into reverse, and this might seem for your generation a long way off, but I'm telling you, for your generation, this is going to be a very serious problem unless people like me get money to do research. That's what I research on, I research on what we're about to talk about, which is dementia. Because the person physically can be very robust, but their mind has deteriorated. They have dementia, a loss of mind. Now, can we understand this loss of cognitive abilities? That is to say, it's not just a loss of memory, it's a loss of the very thing that we've talked about, this personalization of the human brain. A little bit like in this picture, this charming Swedish lithograph of the ages of man, or indeed of women, which could be expressed like this in terms of a single brain cell. So here we have the embryo, the fetus, the early postnatal, and then the mature human brain cell. And I hope you can see that that's characterized, as we've just discussed, by the growth of the branches, enabling you, as you're developing, to make more and more connections. But sadly, I'd like to add, incidentally, that this is not a natural consequence of aging, but it is a disease of older people, which is why it's going to be a burden and a problem for society unless we crack it. And I'll happily answer questions about that afterwards if you wish. But you can see here with the senescent brain, what's happened is there's a pruning back of those branches, which means the carefully crafted checks and balances, the personalized associations that you are fortunate at the moment to enjoy, are gradually dismantled. So no wonder the person becomes confused and disorientated, because they can no longer understand what is happening. They are back in a booming, buzzing confusion. You can't make sense, so they are confused and upset, they feel insecure and worried, because if things happen to you that you can't understand, then it is a very frightening time. But on the same token, you can enjoy the sun on your face, or the grass on your feet, or the taste of ice cream, like a small child would. But you can see why it's very distressing for the carers, because gradually, even someone who means a lot to you, i.e. who would have lots of supernumerary connections, even as they atrophy, you won't recognize the person anymore. There'll just be a nice generic lady smiling at you, when really it was your wife. So a very, very distressing condition. I don't know if any of you have elderly relatives with it, but that's how we can understand the loss of mind that we call dementia. So we can also, on a lighter note, carry on with this notion of mind by talking about blowing the mind and losing the mind, and so on. Now, I don't know if there's any classicists here. This is one of my favorite plays, Euripides' Bacchae. And for those of you not familiar with the play, it's about this poor King Pentheus, who was stupid enough to try and suppress the revels of these women who were paying libation to the god Dionysus, the god of wine. And you see them here getting into a frenzy. The king is in the middle, about to be torn apart by these mad women. Because he hasn't paid attention to the words of a wise soothsayer, Tiresias, who's told him there's two forces, the wine force and the bread force, and you need both in life. So this is something that we've been familiar with since human beings stalked the planet as part of being human, which is this notion of letting yourself go, having a sensational time. I think that is very telling when we talk about raw senses. If I said to you, tell you what, let's abandon this lecture now, let's all go out, have a sensational time, you might want to do that with me, but if I said, let's go out and have a really cognitive time now, I don't think anyone would find that a particularly attractive prospect. So it's something that we've always wanted to do. Let yourself go, you see. So you might do this is the kind of thing you might do. Now, what's happened in the backy up there, and some people, if they are ditzy enough to take drugs, same kind of idea. What you're doing there is interfering with the chemicals that act as transmitters between one brain cell and another, so the connections won't work so well, so you're reducing the efficacy of your connections to deliver for you a cognitive experience. Here, what you've done, or what people do, is they put themselves into an environment that's dominated by the senses and is very fast-paced. I don't think these people are thinking metaphorically here. You know, they don't think, what does the water mean? You know, the water is the water, yeah, and it's there, and they're having to combat it. So you put yourself in a fast-paced environment dominated by the senses. Of course, the same could be said. Now, forgive me, I don't know what the current word is for raves or clubs, or what's the current word that you'd use when you go out and you go sort of techno, 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 and you're in a world stripped of all cognitive content where the premium is on the beat of the music or the lights, and let's hope not too much olfaction or tactile stimulation, but nonetheless, it's a world that is reduced to raw sensation rather than the cognitive, yeah? Deliberately. I got this, I don't know if there's any Aussies here, I got this when I was in Australia, I couldn't resist it, advertising hovercraft fun rides in northern Queensland, where the whole selling point is to be totally out of control. Isn't that interesting? They paid money to look like this, you know. It's quite interesting that people do this. And then for the more sedate here is Fragonard Swing. You know. So this, I tried to here just get a range of cultural and different eras for showing that it is part of human nature to let yourself go, have a sensational time, to blow your mind, to lose your mind, to be out of your mind. The very word ecstasy in Greek is to stand outside of yourself. And as Euripides very wisely said, sometimes we pay money, well, he didn't say we pay money, but we do pay money to do this. It fascinates him that we do. But drugs and sex and rock and roll, wine, women and song all have in common with this notion of the abrogation of the sense of self, albeit on a temporary basis. Anyone who tries to dance and is self-conscious knows how useless that is. So you're no longer self-conscious. You're conscious, but you're not self-conscious. You're just a passive recipient, once again, of your senses. You've gone back to the world of the small child. But normally, we don't want to do that all the time. I think we'd all feel rather sad for people that say they just want to be on the beach or the bar or the bedroom all the time. The very fact you're here this evening means that you don't want to do that, because there's also, in adult humans, something else, some notion of individuality, some narrative, some sense of self that we feel we want to fulfill or preserve. So that's just my overview of how we can interpret the adult human mind in terms of brain connections, and how we can suspend those personal connections, either chronically and irreversibly with disease, or sometimes by drugs or the environment when we choose to do that. Okay. So, here you are, therefore, living your life. This is sometimes, people say downtown Oxford, that's how they think of us, but I don't have to say that to a Cambridge audience, here we are. Living, the reason I'm showing you this picture is everyone's living their own little life story, just as we all are. Everyone's got their own past and present and future, their own trajectory in time and space, that even if you're a clone, you are not going to emulate precisely. We all are living a unique life that no one else has ever lived. For 100,000 years we've stalked the planet, nor ever will again. And that unique life is embedding itself, everything you do, on your brain cell connections. And that is what I call the human mind, and that is what makes you so special. Okay, so I'd like to suggest to you that the biological basis of the mind is this personalization of the brain through these dynamic configurations of neuronal connections, driven in turn by unique one-off experiences that no one else will ever have again. And each will then build up into this narrative, this story, this increased personalization of your brain through your brain cell connections. So, if that's the case, what's the future hold? Well, this is my overview of the future. Let me just say first, what I'm going to say now is the first step in this syllogism is the human brain is sensitive to the environment. I'm about to now say the environment is changing in unprecedented ways, so that we will then consider whether the human mind will change in unprecedented ways. I think most neuroscientists will take it as a given that it will. The issue is it good or bad, and how do we harness it, how do we maximize the opportunities and minimize the threats? So, let's think as an overview about the new environment. I'm pleased to see there's books on sale outside. This is summarized in Tomorrow's People, which I wrote a while ago. Anyway, if we think about information technology, that can be a merging of the cyber world with reality, and we'll come to that in more detail. Let's think a little bit about nanotechnology, which is engineering on the scale of a billionth of a meter, which will therefore change the properties of materials. I don't know if there's any material scientists here, in which case you can come up and amplify what I'm about to say, but it will mean that properties, because the surface properties will change, that we are looking at a world that will have things in it that we're not familiar with, in a way that trying to explain to someone a wattle and daub hut in the Middle Ages what plastics were and how plastics would change the world would almost have been impossible. And I think we are looking at that with nanotechnology and how it will make aircraft 50 times lighter, frictionless ball bearings and so on. So frictionless, so it's going to be very, very different, merely in terms of the materials, which I'm not really able to comment on. What I am able to comment on is the biomedical applications, because it will mean that there is an interaction of your body with the outside world that is much more intimate. So, for example, one idea is that you could go, and this is already apparently in development, you could go and clean your teeth in the bathroom mirror, and the toothbrush will speak to you and will say, you better watch out, if you carry on like this, you'll lose all your teeth in 10 years' time. You've got gum disease. Yeah? And somewhat sobered, you then urinate in the lavatory pan, and the lavatory pan, also being smart, will analyze your glucose in your urine and say whether you've got diabetes or not. It could mean going to the bathroom is a whole new ballgame than what it is now. Or someone said it's where everything will be interactive and everything will be smart. So a table won't be a table, it will be things that interact with your body. Already these things are happening, as we know. You can order things in certain restaurants with your fingertips and so on. So, but even more, it will invade the body. And further than just monitoring glucose levels and tooth decay, it can also, and already this is happening, actually interface with the brain. And there's some brilliant work by someone called Miguel Nicolailes at Duke University, where in quadriplegic patients, let's say people who are paralyzed, he's able to pick up the electric signature that would normally precede a movement, and we saw that that happens from those brain scans. Feed it into a computer so that when the person wishes to move again, the computer will recognize that pattern and operate a prosthetic arm, so that now you can have someone who's completely paralyzed willing something to happen, and it will happen. Quite remarkable, wonderful use. So we are breaching the firewall of the brain and body. I don't know if anyone will want the email sent in that way automatically, but anyway, it's another thought. And then we come on to biotechnology. And again, this is just an overview and a summary. But if you think about the generational divide, we would normally evaluate someone or allocate them to a generation, obviously on how healthy they were, what they looked like, their reproductive status, and whether they're working or not. So let's just think about that, because I'm going to suggest to you that that will blur hugely, in that what one could have in the future is obviously we're going to live longer and healthier lives. Your life expectancy, certainly that of your children, could realistically be 90 or 100 years of age, which in itself is a separate issue on what you're going to do with all that time, but we'll park that for the time being. If you are healthier, whether you like it or not, you look younger and you look better. And I don't want to get too high-minded about this, because what is a cosmetic problem for some person is a medical problem for someone else. So, for example, stem cell technologies can be used for male pattern baldness. And the two go together. The healthier you are, the younger and healthier, obviously, you will look. So one can end up thinking of a more standardized group of people. With reproductive technologies, soon, not just could we freeze a woman's eggs, but you could thaw them as well, so that a postmenopausal woman, if she didn't mind IVF, could have a child at any age in her career or whatever she wishes to do. Going even more speculative, you could contemplate extracting the genetic material from any cell in the body, combining it with anyone else's, and with IVF, anyone of any age or sexual orientation having a child with anyone else of any age or sexual orientation. So a child could theoretically have 6 parents, the 2 genetic donors, the donor of the egg, the donor of the womb, and the people that brought it up, in theory. And I'm not saying that's a good thing, but you could have 6 people claiming parentage of one child. And moreover, it means that we will no longer respect the generations. And perhaps the easiest one that we're realizing already is, with the advent of all this technology, there's no longer a premium on how strong you are or how mobile you are in terms of physical labor, because increasingly work will be brain power type work, which an older person or a less mobile person could do from home. Given already the pensions are being raised, pension age is being raised, the government can't afford to pay old people any more pensions. Soon, and they're scrapping retirement age. This surprised me not one bit. Soon they'll be saying it's good for you, it'll stimulate your brain. And so what will happen, therefore, is the normal demarcation of work, appearance, reproductive status, and health will be very merged, perhaps even homogenized. So you can imagine growing up, being an adult, looking pretty much like everyone else, because everyone will have, perfect features have been done, and no one will be bald, no one will have big noses. So you grow up, everyone looks pretty much the same, everyone reproduces with everyone else, and then you die. Yeah, there we are. Oh, you work all the time, of course, as well. That's the other thing. Yeah, and then you die. So that's one scenario, which you may or may not want, but we have to think about. But what's in common with these the three technologies, information technology, nanotech, and biotech, is that they are challenging and blurring compartments that previously we held as given. Anyone up until our generation, our era, would have never had a problem distinguishing what was real from what was fantasy, as long as they were sane. What was one generation versus another, and what was your body compared to the outside world. But now I think that's what the technology could be doing. Let's concentrate, however, on the cyber world, which is the most immediate. And I should do as a health warning here. I'm sure many of you have perhaps seen me in Google or were the victim of Bengoldacre or something, where it's Baroness says computers rot the brain and all that. I've never said that. First, what I have said, however, is as a neuroscientist, obviously the brain is going to change. If the environment is changing, we need to work out how, and we are not helping anyone or doing on any favours if we're complacent and arrogant and hostile, and we have to really talk about this because it is a big issue. My own view is it's equivalent to climate change, and I'd like to call this mind change. One of the issues we start with is, for example, this statistic between the child's 10th and 11th birthday. You can see they spend 900 hours in class, just under 1,300 hours with their family, and look at that, just under 2,000 hours in front of a screen. So let's now think about some of the things that might mean. Just to show I'm not the Luddite I'm portrayed as, let me say some nice things about these technologies. This is a very good book by Stephen Johnson, and as you can see, the title speaks for itself. And what he says is there's some really good things. For example, the rise in IQ. And it's acknowledged across certain societies that over the last few decades, IQ has been rising. And he suggests that this might be because when you do an IQ test, you're rehearsing the same skills as when you play computer games. That is to say, you're using very advanced information processing, mental processes are a premium, and you're looking for sequences, seeing connections, seeing similarities, and within a certain time, coming to the answer. But he also says, and I think this is very important, that just because we've seen a rise in IQ, what we haven't seen is an increase in symphony writing, or an increase in novel writing, or increased insight into the economic situation. So surely IQ tests don't encapsulate everything, okay? So we have mental processing, information processing, but there's also something else as well, and that is understanding that I mentioned earlier on. So one can think about rescuing the princess in a game, but you don't really care about the princess, doesn't mean anything to you. We'll come on to that in a minute. But what a screen does is it has to compete with the real world, and it does so very successfully. Now, why is that? It's because the images that are put on are supranormal. It's able to draw your attention to it rather than to anything else, and then it fragments it because there's usually many things going on. So it's a bit like driving. You have to be very good at information processing. In fact, you adapt to become a computer yourself, making very efficient responses to a complex and fast-paced interactive environment. And that gives you certain qualities, certain skills, but not others. So let's think about the things that it might give you. Multitasking, I wonder if you'd like a loo like this, where you could go and multitask even when you're in the lavatory. Multitasking isn't all it's cracked up to be. Look at these brain scans, where you have people just listening and then just seeing, and when you're asking someone to do both, then there's less listening with more multitasking. So the brain only has a limited capacity, and the more you give parallel inputs and ask it to do more, the more it will do those things, but what you gain in breadth, you lose in depth. So another issue, and this is where I'm going to start, I hope I don't want to sound too negative, because I think these things are not doom and gloom. I think we just need to be aware of them so we can start to think about how to harness the technology to minimize some of these problems. Methylphenidate, you might know better as a drug called Ritalin, which is used for attention deficit disorder. And you can see here the change in prescriptions over the last 15 years or so. Now, why is this? Could it be that doctors are prescribing more liberally? Possible. Could it be that we're now recognizing it as a medical condition? Possibly. But not mutually exclusive with those two ideas. Could it be that the environment is changing in a way that mandates a shorter attention span? Now, that I can't prove, but I think it's something that we shouldn't automatically exclude a priori. Because imagine if you're a very small child and you're with parents who see a wonderful electronic babysitter in the screen, and children do have a fascination for that. Could they therefore be developing or rehearsing? Because remember, the brain will always adapt to the environment in which it's placed. And if it's in place in this kind of environment, what do you think it might do to the connections if it's, say, 6 hours a day or more? So let's just look at this. Okay, some of you may recognize that as World of Warcraft, where obviously the pace there is faster, the images are much more novel and unpredictable than in real life, and one doesn't have time to really think or contemplate about what's happening. You're responding and living in a very exciting and highly aroused state, one that is, by definition, strongly sensory. How would you do out brief candle, I wonder, on the screen? A child lives in a sensory world, as we've seen. Notice with this little kid, as soon as the toy is obscured, the child's looking off somewhere else. If you say if a child dropped an ice cream, say, perhaps you've got younger brothers or sisters, you can get around that by saying, oh, look at the bird, and the kid will suddenly look up and be completely distracted. If you have a depressed adult in tears and you say, look at the bird, it doesn't really do much good to them. Yeah, so we know that because they are living in a much more robust and strong cognitive world rather than one where you're just driven by senses coming in. So the next issue is this lack of metaphor that does concern me, because I do think that part of human thought and reasoning and understanding does depend on making connections, making associations, and indeed on abstract concepts. Just to see how far one could go with the screen with an abstract concept, so if you take a word like honour, and honour is a very subtle, difficult, complex, multi-layered word. If you Google on images for honour, this is what you get. And I just wonder, if you showed that to a Martian, would they have any idea what honour was? They couldn't. How can you show honour visually? Whereas I'm sure many of you read Mallory, for example, and Mort Arthur. Yeah. That is how you get a notion of honour. So I know I'm coming across as some crusty Luddite, but I'm just sharing with you the areas I feel that we may be losing out on, that we need to create or help people benefit from in the way that you have and I have with our privileged educations. So we get on to process and content. We mentioned being able to do things quickly, and here we are rescuing the princess, the noble Princess Yukihime, having been kidnapped. But you don't really care about her, I don't think, in the way you would care about Princess Maria in Tolstoy. And that is because when you're playing a process, when you're information processing, that is not understanding. That is doing something you need to do. It's like when you drive. You need to be able to respond quickly to inputs from the environment in an interactive way. But that is not the same as being able to have the time in a linear way to see one thing in terms of something else. Only then will it have a significance. Okay, only then will it mean something. Your own life, for example, is seen in terms of the past and the future, the same as a fact is seen in terms of how it relates to other facts. And you need, in order to associate those facts, to access them and to forge them, sometimes, as we all do, you put the book down and you stare at the wall. Or if you want to get something clear, you say, no, let me write this down. You know, you have a problem with someone, you say, no, let me write you a letter, let me write it down. Then I can think straight. We talk about thinking straight, thinking in a linear way, where one sequence leads on from the next. Reduced empathy, which, again, concerns me, and I would say is evidenced by, I gather it's called happy slapping, a monstrous phenomena, which I gather is where people are bullied or physically tortured and it's put on YouTube. Now, what kind of people would do this? What kind of... And I can't think that they're sadists. I think it might be worse, is that they don't understand that someone might be suffering. They don't understand what that is, that red stuff coming out, what it feels like to be someone else. So let's think about empathy and reduced empathy. These little kids are not communicating with each other. They are communicating with the computer, or through the computer. But what's interesting, what they're missing out on, is what happens when you talk to someone face to face. Eye contact and body language account for 55% of the impact you have when you first meet someone. Voice, tone, rate, volume is 35%. No one has yet quantified pheromones, those sneaky chemicals, and everyone knows the power of a hug. When someone's upset, say, you don't bother talking to them, you put your arm around them. And even professionally, as you can see there, the reassuring left arm of the guy shaking hands, obviously doing some kind of deal with the guy on the right. So none of these things are available on Facebook. Eye contact, body language, voice, pheromones, physical contact, and they are absolutely essential to human interaction. When you look someone in the eye, this is something that you've learned, although you don't realize it as you've been growing up. We know that according to how close you are to someone and the nature of your relationship, whether it's professional or private and so on, that will determine how much you look someone in the eye. When you look, if you stare someone in the eye all the time, they'll freak out. If you don't look at them in the eye at all, they'll freak out. And it's carefully calibrated how much you look away, how much you come back, and so on. And all these skills don't just come. They don't just come. You have to actually rehearse them. So my fear is that if you don't rehearse these things, when you are confronted with someone face to face, you'll find it aversive and uncomfortable, and you'll retreat to having your 900 friends. I met someone who had 900 friends the other day on Facebook. You'll retreat to that rather than the more demanding and difficult and uncomfortable, possibly, interaction with people. If you don't do that, what kind of world are we going to have if people can't know when to hug each other and how much they should look at each other? Words are only 10% of the impact, say. So, no wonder that if you haven't rehearsed those things, you're not going to read body language, you're not going to empathize with someone, it's going to be harder for you to pick up on those things, and that's already, of course, what autistic spectrum people suffer from. And what's very interesting with autistic people who do have a problem with reading and understanding how people are feeling, they need to be logically explain why they're upset and so on, where actions speak louder than words. And autistic people are very comfortable in Second Life. They really like Second Life. I don't know if anyone here, because that is more action than thought or feelings. And I'd submit that when we are doing these things, we are all autistic, because there's no need or no ability, no facility or opportunity to look at body language or voice tone or have tactile input to someone. Everything is reduced to just action, much more. What you see is what you get. Could this account in the future for reduced empathy? Now, along with that is identity. We've talked about significance being seeing one thing in terms of something else. Let's think now about an event being significant. If I dropped that pen on the floor, I'm going to drop it on the floor, and now I'm going to pick it up. So I've completely reversed that action. It was therefore, I think you'd all agree, a meaningless thing to do. It means nothing. I'd like to suggest to you that meaning is when there's a degree of permanence. That and in real life, of course, most things do have meaning because they have permanence. Although you might do something for which you apologize, or which you can offset, or which you will do differently in the future, you can't undo what's happened. You can't make someone undead. You can't unsay an insult. You can apologize for it, but you can't unsay it. You can't reverse. Actions have consequences usually, and therefore they're meaningful, and that's what gives you a meaning to your life, because as you are doing one thing in terms of something else, you have a beginning and middle and an end, and it's meaningful. Like when you read a book, it has a meaning because one thing, once it's happened, can't be just undone. But when you play a game, you can just play the game again. And so a game for young children, perhaps who do this excessively, they're learning a very dangerous lesson, which is actions don't have consequences. Now, if you're doing something, therefore, that doesn't have consequences, and if, therefore, it doesn't have meaning, if you're doing something all the time that is meaningless, what would that say about you? If you're just living in a world saying yuck and wow all day, and living in the moment, it can be exciting and arousing. But eventually, if it doesn't have much meaning, what will that say about your identity and how you see yourself, I wonder? What will it say about people in the future? And I couldn't resist this history of blogging, which I think might answer partly that. 1999, e-blogger, I just have to tell something about this thing my cat did today. 2004, oh my God, cat pictures. YouTube, 2005, moving cat pictures. 2007, that pinnacle of civilization, Twitter. 1 p.m, my cat just sneezed. 1:02, cat sneezed again. 1:04, cat hasn't sneezed recently, getting worried. Yeah. Does anyone truly care? Yeah? Now, I would say to you that these are people in existential crisis. Yeah? These are people like small children. Look at me, mummy, I'm doing this. Look at me, I'm doing this. Because if you don't look at me, will I exist? Okay? Will I have a robust identity? Now, that might sound exaggerated. In fact, someone took the piss out of me on YouTube once when I was saying about the socks, and they did a film of themselves putting on both socks at once, which was quite funny. But this might sound, kind of overly exaggerated, but I think we should think about it. Who on earth cares about this flood of consciousness from Twitter a lot of the time? Who cares? Now, I know before you tell me that Twitter's been very useful in Egypt and so on, and of course, and I'm not criticizing the technology, I'm criticizing the use of the technology by some and what it might mean. Technology is just fine and can be very valuable in certain parts of the world and so on, but that's not the issue. The issue is who really wants this solipsistic flood of consciousness? Who's going to listen to it? Who cares? Why are we doing it? Why are we so important and special that other people care about these banal things? If you just discovered how brain works, that's fine. 1 p.m., discovered how consciousness is generated in the brain. Yes, that would be interesting, but that'd be fine. But why don't people reserve it for that? Yeah? Then the challenge would be to do it in 150 characters, which would be quite good. Anyway. So that is what I'd like to just say about identity. We can come back to that. Risk-taking is now this is really important because in the future commercial world, you'll find people talk about risk management. Obama said that the current economic crisis was caused by greed and recklessness. And I'd like to talk now about this being another issue, that if actions don't have consequences, what will it mean for you, if you're doing this all the time, about how you take risks? So let's think about recklessness. Now, if you ask a neuroscientist to talk about recklessness, they will immediately come up with neurological conditions where people are particularly reckless. And that gives us a clue to what is happening in the brain when people are taking risks. So let's think about that. This is a case that's very famous. The first case of a neurological example of brain damage causing recklessness. And it's someone called Phineas Gage, who you may have heard of, who was the foreman on a railway gang in Vermont in about 1860. And I'm going to show you something gory. If you're particularly squeamish, you might want to close your eyes. There we are, that's him. And he's holding something called a tamping iron, because what happened one day, he was pushing explosive down a hole with this iron because he was the foreman on a railway gang and they were exploding rocks out of the way so you could lay railway track. And the explosive went off prematurely and drove this tamping iron through his head, as shown here. And amazingly, he survived and actually went back to work because he could walk and talk, amazingly. His senses were all working. But it was only after he'd gone back to work that subtle differences became apparent, most specifically that he was excessively reckless. If you want to know what happened to him, he became so difficult to work with because of his now frontal syndrome, as it was called, including recklessness, that he had a far more lucrative living as a fairground freak, showing off his wound, and he earned so much money he could afford to become an alcoholic and died of alcohol poisoning. That's him. Anyway, so if we look at this frontal part of the brain, which is called the prefrontal cortex, which the tamping iron had gone through, this is an interesting area of the brain. It occupies 33% in human brain, but only 17% in chimps and only 3% in cats. So it's, in evolutionary terms, an extremely new area that's become very exaggerated in us. And it's posed a great problem to many neuroscientists who use it as a kind of kitchen sink for putting all sophisticated cognitive functions in. It's not quite like that. It's more that it connects up with the rest of the brain and has therefore a kind of cohesive function, a glue-like function. The reason I mention this, it's a very interesting area because it does seem that when it's damaged or when it's under-functioning, people are more reckless. And this is a brief film of a modern-day Phineas Gage, a man called Michael, who got shrapnel in the Vietnam War in the front of his brain, and you'll see now the kind of task that people can do to show recklessness in people. So let's just look at Michael here.
X-rays revealed that shrapnel from the grenade had penetrated the front of Michael's brain.
Can I turn it down a bit? Is that too loud? It's okay.
Transformation. Okay. Before his injury, he was a bright and very promising and assertive soldier. And subsequent to his injury, Michael became unemployable, made many mistakes in social behaviors and relations, and has to live a much more limited life now.
Demoted and eventually discharged from the army, Michael has been unable to hold down a steady job. He's now working under supervision as a hospital janitor.
I'm going to start out by giving you 10 chips. Each chip is worth 5 cents.
Dr. Jordan Grafman is trying to establish why Michael's life has fallen apart. What aspects of his mental abilities have suffered because of the damage to his frontal lobe?
8, 9, 10.
This gambling task is designed to test his ability to weigh up the likely consequences of his actions. The point of the test is to see at what stage in the game he decides to stop.
Do you want to stop or do you want to continue?
Continue. High cards, Mike wins a chip. 10 or less, and he loses one.
Continue.
The cards are deliberately arranged to give him a good winning streak, followed by a steady run of losses. Normally, people stop while they're ahead.
Continue. You should have kept it. Continue. Continue.
That's it. We're at the end. You gave me back all your chips.
Okay, so that's an example of the kind of tasks that you can evaluate recklessness with. Now, what's really interesting, as you can see in this paper, another group of people don't have to have damage to the frontal part of their brains, but nonetheless they make the same kind of exaggerated behaviors, and these are obese people. There will be a point to this, you have to trust me, over the next 5 minutes. We're just going to look at cases, because obese people, and that, bear in mind that's another issue that you're going to be facing in your generation, they don't have physical damage, but they have metabolically underactive prefrontal cortex. It's an inverse relationship to their body mass index, and you'll know that that is how heavy you are relative to your height. So the higher your body mass index, the heavier you are relative to your height, and the heavier you are, the less activity in your prefrontal cortex. Okay? Then there's another group of people, and these are schizophrenics, and you can see here, with schizophrenia, there's an underactive prefrontal cortex. They're lying on their back, nose in the air. And similarly, what's interesting about schizophrenia, which is characterized by a distraction, by a premium on the senses coming in a lot, it's actually very similar to childhood. Schizophrenics and children are easily distracted, they have a shorter attention span, and they can't interpret proverbs. So if you said to a schizophrenic, people who live in glass houses mustn't throw stones, what does that mean? They would say, well, if your house is made of glass and you throw a stone, your house will break. Rather like my little brother didn't know what it meant by saying, out, out, brief candle. And finally, they have, in both cases, an underfunctioning prefrontal cortex. What's very interesting is the prefrontal cortex is, in evolutionary terms, but also in developmental terms, very late. It only is fully active, the prefrontal cortex, in late teenage years, which is quite remarkable. And you can see here the doctor that attended Phineas Gage said he has exceedingly capricious and childish, a child in his intellectual capacity. Okay, so we've got a group of conditions here that seem very different: childhood, eating a lot, gambling, and schizophrenia. What could they have in common that all is characterized by this underfunctioning prefrontal cortex? Well, I think the clue comes from this series of very famous paintings by a schizophrenic, starting off with a cat, and this reflects the deterioration in the condition of the patient, in psychiatric terms. And the cat, you can see here, is a very cognitive cat. Everyone would recognize this as a cat. I bet you would never say that was a cat if I just showed you that. I used to do this for entrance exams for medicine, actually. I used to ask people at Oxford how they would interpret this. It's all quite interesting. No one would ever see that as a cat, ever, obviously. And so what's happened is, of course, one, perhaps in artistic terms, I think that's better, but in psychiatric terms there's a deterioration. What's happened is we've gone here from the cognitive to the sensory. This is the conglomeration of abstract sensations. Could it be, therefore, that the common factor is the senses are trumping the consequences? Anyone who eats knows the consequence of eating, but for obese people it's that the thrill of the food trumps the consequences of putting on weight. Anyone who compulsively gambles knows the consequence of gambling, but the thrill of the roulette wheel, the roll of the dice and so on, trumps the consequences of going bankrupt. And children haven't had enough life to appreciate the consequences. They like the thrill, as we've seen, of the senses. So if that's the case, you'll probably see where this is headed. Let's think about screen technologies now. They offer you high arousal. They're very exciting. In some cases, they're addictive, and they are presumably rewarding. Now, in brain terms, there's one chemical in the brain that isn't the chemical for arousal or for addiction, but which helps mediate those conditions, and that's a chemical called dopamine. And dopamine is like a fountain in the brain. Here it is, appearing at the base of the brain. And its many actions, one very important one, is it dampens down action in the prefrontal cortex. So you probably can see where this is headed now. Let's think about that. could we have two basic modes for the human brain? And let's leave aside screen technologies for the moment. One where the prefrontal cortex underfunctions and one where it's activated. In this world, the prefrontal underfunction, you have strong feelings. Here, on the other hand, thinking dominates. It's sensory versus cognitive, as we've seen, because this is coming on later in life. Here, you're living in the here and now. Here, you have a sequence, a past, a present, a future, a fantasy. Here, the external environment is driving one moment from the next. Here, internal perceptions dominate, this continued sense of self, this robust cognitive narrative. This has little meaning. What you see is what you get. After all, you've let yourself go. Here is a personalized meaning, where those connections are really working big time. Reduced sense of self versus strong sense of self. No time or space, you're just in the moment. Here, clear events. This characterized mainly by infants and children, unless you've taken drugs or gone skiing or having drugs and sex and rock and roll or wine, women and song. Here, older children and adults. Here, more dopamine, because it's suppressing the prefrontal cortex. Here, less dopamine. Now, that's always been the case, I suggest, but could it now be that the change is that the world on the left is going to dominate thanks to an environment that predisposes you to do that? So, just to summarize, and I ought to stop soon because I'm getting short of time, you can imagine intense stimulation of the screen mandating fast responses. In turns, those are highly arousing, and that will always be associated with levels of dopamine because that's released during arousal levels. Dopamine underlies addictive behavior. Every single psychotropic drug, irrespective of its initial target chemically, whether it's amphetamine or heroin, they all will lead finally to the release in a part of the brain called the nucleus accumbens of dopamine. That's the final common path for addictive drugs. Once dopamine is released, it will cause hyperfunction of the prefrontal cortex, bringing about conditions or mindsets similar to childhood schizophrenia or obesity, characterized in turn, because there's less cohesion, to a drive for sensation rather than cognition, which will, of course, make screens more exciting. So that's a model that I think might be happening. So what will happen in the future, possibly? Well, I think it's good and bad. We could have a higher IQ, shorter attention span, improved short-term memory, but a premium of icons or images over concepts, an emphasis on sensory rather than cognitive, less empathy, less risk-averse, and less sense of identity. Some of these things are good, some are bad. These are my own value judgments of the green things being good, the yellow things neutral, the red things to be avoided. And really, it's for you, your generation, not to just say this is all rubbish. Of course, no one's going to change me, I'm inviolate. You're not doing a service to the next generations. I think what we need to do in society is to think, because the brain is so sensitive to the environment, how can you make the environment not just good for you, but for your children and your grandchildren? Thank you very much.
Yeah,
a few minutes for questions.
Some people have something at 7:30, which they'd like to get to. I think we're just going to have a few questions here. And if you have any more, we'll be in the bar, and the Baroness will be sending.
Yeah, I won't be in the bar. I'll be. Yeah. So, yeah. Okay, so it's the condition that has to be treated when people are hyperactive and easily distracted. Now, it might be that you're in an environment when you, and I'm not necessarily saying you're typical, and I always am nervous when people use themselves, or they say their children, because, let's be honest, we all come from environments where you would have had parents who didn't just park you in front of a thing and probably did other things. Well, I don't. But without getting, as I say, personal, the issue is, in a sense, when you're playing a computer game, yes, you're concentrated, but you're constantly having feedback. You're constantly doing something. Yeah? You're not required to just sit. Yeah? You're doing something. Yeah? Whereas a long attention span is where you're not having a constant interaction, but you are much more passive. And imagine that when a kid then goes to school and they're asked to sit still and do nothing, but just listen, then because they're not doing something immediately back and interacting, that they may want to do that, and therefore they'll be called fidgety, and then they'll be diagnosed as hyperactive, and then they'll be given an amphetamine drug.
Okay.
Yeah. Yes, up there.
Hi. It seems to me that whilst a lot of your conclusions about what the future of the brain might be like are very plausible, seems at the moment relatively speculative. How would you go about testing something?
Well, I'm glad you asked that, because I do a lot now, increasingly, talking with schools, and you'll be amazed at the feedback I'm getting from both primary and secondary schools as to, in fact, I'm going in on Monday to Reading, where they actually want to sponsor a project where we can evaluate this. Okay, I think the first thing we need to do, and what I'd like to do, is to have a real proper snapshot of what parents think, because very rarely parents are canvassed, and sometimes when I talk anecdotally to them, they say, oh, my 12-year-old spends all the time in front of a computer. But that hasn't been in any way formally done as a proper survey, it's just concern. I'd also like to know what the teachers think, because again, teachers that have quite a lot of experience have noticed changes in their pupils, but this hasn't been quantified, it hasn't been formally reported. And also, I'd like the kids themselves to say, I'd like to know, I don't think we've got much data in this country, apart from the one I showed you, on how it breaks down, because the issues with the screen technologies is it's not just are computers good or bad, any more than you'd say is a car good or bad, it's sort of meaningless. There's one issue with identity and social networking, there's another with risk-taking and gaming, there's yet another with learning and how you access search engines. All these are very separate issues. And I'd like to see with kids what they do most, what they think, and so on. So the first stage, what we'd like to do are some surveys, proper surveys, and in the light of those surveys, I have my own ideas for some software that could combat some of these things. I'd like then to sort of test it out on those, and then just test and see if it does make a difference. So it's very hard to prove these kinds of concepts, because you can't wait around while someone grows up, and then see what's happened, what kind of people they are, and also get controls. I mean, you could do little psychology experiments of getting one group to hypertext and someone else not, and seeing how much they've understood or not. And that is showing actually there's differences. For those of you who are interested, there's a book by someone called Nicholas Carr called The Shadows, and another one called Future Minds by I think it's someone called Watson, where they document those kinds of studies, which are for the neuroscientists here, in a journal called Neuron, a very high-impact neuroscience journal, in September of last year, there's an article by someone called Bavalier, a review article, where she says she's mainly worried about violence, distraction, and addiction. And so the evidence is starting to come, but evidence of absence is not absence of evidence, and one has to be very careful that doesn't provide an excuse, as it did for people in the 50s, to say there's no evidence that smoking is bad for you and therefore it's okay. So I think we have to be alert to this. You're right, we have to flag and get as much evidence as possible, you have to test it, and it's by these kinds of discussions and thoughts and by just talking about it that eventually one can get that sort of thing going. I think probably time for one more question. Yes, then. Okay. Are you asking a joint question, you two, are you? Okay, take some of the quick questions.
Can our thoughts be generated in other tissues apart from brain?
Can the thoughts be done?
Thoughts, thinking process.
Oh, thinking. It's interesting. You may be familiar with the work of Antonio Damasio, because one of the big issues, and I'd subscribe to this idea, is that the brain doesn't work in a vat. The brain is part of your body, and it interfaces with the other great control systems of your body. That's the endocrine system and the immune system, and the central nervous system. Otherwise, you'll have biological anarchy. So the three have to work together. And he argues for chemicals called peptides, because these are kind of trilingual compounds that are released from the gut that can work in the immune system and can work in the central nervous system. And one might argue that these peptides that circulate round and unite these three control systems could actually, it's not that one organ thinks, well, it's that the whole thing goes together. And your question?
If you could prove a causal link, how would you legislate if indeed you would?
I think it's really interesting to distinguish between regulation and education. And in fact, I first started doing this, not because I normally work on Alzheimer's, but I gave a speech in the House of Lords on regulation and social networking sites about 2 or 3 years ago, in February, I think it was 2009, which if you want to look in Hansard. And because I'm a scientist, I didn't talk about regulation, I was talking about education, what this might mean. And things went ballistic after that, in the media terms. Everyone finally found this really interesting. And I think the issue is to try and, my own view is not to tell people not to do things, because as an ex-smoker I know that if you tell someone not to do something, that's an incentive to do it, of course. So what you must do is to give people insight and empowerment. And it's been shown, for example, in the States with educationally low achieving kids who think they're born thick. If you tell them about how the brain works and plasticity, that actually improves their educational performance. It's really quite amazing. So I think what I would like to do is not so much invent rules and laws, but rather raise awareness, then people can make their own choices. I think probably we ought to stop there. Okay. Thank you very much.